Well, I don't think I just like, wait, no, first I'll do like the pi over two squared, because like that's just better, and I'll like, the pi over six, and then I'll do those two. And then because all like the pi over fours are always gonna have. I guess
Oh, we treat it, but. Okay, so did you get some good tips for next time? Did you learn anything? Did you teach anything? I'm going to talk to you to find out. Now, when I collect this, there are 12 of me today. I don't want to collect it from 12 different people. I like to try to be efficient. So I'm going to ask you to pass it up and just hand it to one person in your group. So just collect it from 3 people. Perfect.
I would.
Oh.
No, yeah. I'm not like with moderate. Okay, yeah. Yes, that's make your own. It's sad. But she has eyebrows. She like if I ever
Okay, so let's take out our packets. Did something like this last time. Page 7.
Yeah, but like this.
Oh, yeah. Oh, I need my microphone. Okay, so I'm gonna kind of pick and choose my way through this section. I'm not gonna do a lot of it. I'm gonna skip through some of it and then get back and clean up some of the others. But I want to get to some of the conceptual stuff before we details. Like when I'm talking about domain and range of trig functions, I'm actually going to talk about that next time or another time. Period, another time. I want you to, let's do 12 and 13 though. Do you know what an identity is? What's an identity? Like, you know, like your identity, you have an ID card that establishes your identity, but like an equation that is an identity, do you know what it is? Yes, Ria?
It's like something that never changes, or it's like something that you use to do. I don't know.
It's like a shovel.
Like
it's kind of like there are definitions that are identities for sure. And you're exactly on the right track. Does that sound like what you've done with identity? Have you heard the word identity in a class? Yes, that's before with I know identity property of equality is one thing. I'm sorry, identity property of multiplication is one thing, which is A times 1 is A, that's identity property of multiplication. But an equation that's an identity is an equation that is true for all values of whatever you're inputting, for all values. So there are some identities you need to know, and they coincide with the definitions. You know, maybe you already know the first one. We're in trigonometry. What do you think the first one we're going to do is? Before sine, well, sine is involved, let's say.
SOHCAHTOA.
It involves SOHCAHTOA. The first one starts with a C. Oh, why am I red there? Yeah, I'm going to start with cosecant theta is equal to 1 over sine theta, right? By definition, it's the reciprocal of sine. If we're talking about SOHCAHTOA, the opposite of hypotenuse becomes hypotenuse over opposite. Do you already know the next two? I'm sure you do. Well, I'm pretty sure you do. The next one, secant theta is equal to 1 over cosine theta, and cotangent theta is equal to 1 over tangent theta. There are 3 more. Do you know what the others are? Yeah, sine theta is equal to 1 over cosecant theta. I'll write the others silently as you do it on your paper. Make sure that you're right. And 2 more quotient identities. Anyone have an idea what a quotient identity might be specifically?
Related to division.
Related to what?
Division.
It relates to division and involving trigonometric identities. There are only 2 quotient identities. The first one, yeah, do you know?
So like cosine theta divided by sine theta equals cotangent theta, and then
Nice, yeah.
sine theta over cosine theta is tangent theta.
Perfect. Yeah, I'm gonna start with the tangent theta. For me, that's kind of like a home base with these. And does this resonate with what you've done before? Tangent theta is equal to sine theta over cosine theta? If you haven't, well, welcome to this identity. You do need to know that this is true and that, like you said, Levi, that's perfect. Cotangent theta is equal to cosine theta over sine theta. And we're not going to use this a whole lot today, but we'll be using it and I'll be referring back to it. So it's important to know these reciprocal identities and quotient identities. I may refer to them as rids and quids to be succinct. Easy? Yeah, let's get to the good stuff. Pythagorean identity. Dun, dun, dun. You know the Pythagorean theorem, I know. But the identity, yes, no, do you have an idea?
I think I know. Like
What is it?
cosine theta squared plus sine theta squared is 1.
Has anyone heard that before? It's exactly what I'm looking for. Standard, it's normally the first one. I'm gonna write this, make sure you all understand the notation. That little 2 there is, of course, a square. I'll make it a little bit smaller so it actually looks like an exponent. So when we say this, that means, like Noah said, that's really nicely said. Sine squared theta by definition is sine of theta squared. It means exactly the same thing for sines, for cosine, tangent, all the rest. So why don't we just do sine of theta squared? Why don't we just do that? What's that?
You'd be squaring like the theta.
Yeah, you'd be squaring the theta. Just be inappropriate. So this is fine, except mathematicians like to be as efficient as possible. So they said, well, let's take out the parentheses and put the square over the sine, even though it's not like sine times sine theta. A sine squared of theta means sine of theta squared, just to be clear. And we could see this on the unit circle, can't we? How do you see this on the unit circle? Yeah, Amir. Yeah, remember the whole point of the unit circle is the x value represents the cosine, the y value represents the sine, and the hypotenuse is always going to be 1. So directly from that unit circle, we have cosine squared plus sine squared equals 1, or as I've written it. Now there are 2 more. Do you know how to get the other 2? Yes, Levi.
It's divide by sine squared theta for 1 and divide by cosine squared. It's like cosine squared theta by the for the other.
Yeah, I'm gonna do a little bit of side work and put this over here and divide everything by cosine squared theta divided by cosine squared theta divided by cosine squared theta. And we know from our quiz that sine theta over cosine theta is tangent theta. So since it's both being squared, write this as tangent squared theta plus 1 equals, and what is that? The rid? Secant squared theta. Right, so it's the same thing, just changing the relationships. I'll let you write the other one, because like I said, there's one more. Make sure your neighbor got it. Third one, did it correctly. So the third one, someone who hasn't given us an answer yet today, who'd like to tell us? What is the third one? Someone who hasn't given us an answer yet today? Okay, back to Levi. I think you had your hand.
Yeah, I think, 1 plus cotangent squared theta equals cosecant squared theta.
Are we good? Do you already have this? Nice. Now, you may see things like this, 1 minus cosine squared theta. Do you see that that would be equal to?
Size.
Do you see that it's equal to sine squared theta? Or just taking like this one and move that, or solving for sine, 1 minus cosine squared theta. But they're gonna be moved around and you might not recognize them, but you can always come back to home base. And for me, this really is the home base. It's sine squared plus cosine squared equals 1. And that's me being a little bit lazy, just saying sine squared should be sine squared theta plus cosine squared theta equals 1 better. Just talking to each other, we could say without theta, but don't leave it out if you're writing, please. I always need a angle in there if you are writing. So yeah, this equals sine squared theta, and all the others could be twisted and turned appropriately. Moving on. Yeah, let's do these problems. I'm going to start here. Now, what's the point of the unit circle? What's the point of doing it? We just check in with your neighbor. What's the point of the unit circle?
Be able to come to things like, yeah.
I mean, this.
The graph.
Yes.
Oh, yeah, you've tried, right?
Exactly.
So the whole point of the unit circle is to have fun.
I mean,
That's one of it. That's one. The point of it is to use it so that you can do what? For a few. It really comes down to finding values of sine and cosine quickly. Does that make sense? That you could very quickly find sine and cosine, and from there you could find tangent, since tangent is equal to sine over cosine, opposite over adjacent. You can find those values very quickly. But you don't always have to use a unit circle. Like here, we're going to use an angle. Let's see, the angle is going to be in the first quadrant. It tells us I'm just going to draw an arbitrary angle there. And from this angle, I'm going to make a triangle. That triangle is always made by going directly to the x-axis, always. I'm going to put that in here. Always go to the x-axis. Okay, and tucked in this angle, I could put a theta, can't I? And now what? Yeah, no? Yeah, does that make sense? We know it tells us two sides of the triangle, doesn't it? It says that the opposite is 2 and the hypotenuse is. Do they have to be 2 and 3?
yeah, so they just need to be one.
Maybe the same ratio. It could be 20 and 30, but we're not going to complicate things. Just say here's 2, this is 3. And it's asking us to do all the functions. So I'll make a little table here. Sine theta is equal to this. It already tells us 2/3. Cosine theta is equal to something. Tangent theta. And I always make my tables in 2 sets of 3s. I'd like you to do the same, but there would be no deduction if you didn't. So the next one to do in terms of just low-hanging fruit would be cosecant.
Yeah.
Our cosecant theta we know is 3 over 2. I'll let you figure out the other ones. Check with your neighbor once you're finished. Anyone already finished all 4 of them? The other ones? Cool. Check in with your neighbor, make sure good things are happening there, and you're only working on this problem for now.
Yeah.
Do we need to rationalize denominators or not?
You may if you like.
No.
Like enough. Enough of that.
I'm gonna leave it for now.
It's nice to let it go.
You don't have to rationalize.
It's just a lot. He said we don't have to rationalize.
Unless it's.
So it should be like.
Well, I did rationalize it, I think.
Yeah.
I think.
Always simplify. Like if you have square root of 8 in a denominator, definitely simplify that.
Yeah.
Okay. What do I even do? Like I need to find cosine theta. I have no idea what the other side is, so I have to use Pythagorean theorem, which tells us that that side is square root of 5. Oh, so the cosine is 5 over 3. So I automatically know that the secant is 3 over root 5. Tangent?
Root 2 root 5 over 5, or just root 5 over 2, or 2 over.
Is this okay? 2 over root 5?
Yeah.
You're comfortable leaving it like that? Yeah, that's fine. Cotangent? Root 5 over 2. Such a happy little problem. Yes, Eileen.
But sine theta equals 2/3. Do I have to like put that down on the test?
Good question. It already tells us that it's there, but I like to just be complete. Now, this says find the value of all trig functions at theta. What do you think your best judgment would say? Put it or not? If it's a test. Oh, the question is, should this be part of our answer?
Well,
I mean, it doesn't-
want all the values, so I think it's probably better.
I mean, it doesn't hurt you if you put it down again.
Yeah, it's better to be safe than sorry, so.
Yeah, it's not worth trying to come up, right? It's pretty short. If it were a pretty long thing, then maybe. I don't know. It says find the value of all trig functions. Okay, here. So I found it. It's given to us. Yay. But yeah, when in doubt, just do it a little bit more. If you find that you have to do a whole other problem, continue using your best judgment. Because chances are that information is given to you, whether or not you should be going down a whole other route. Before we do this problem, I want you to discuss with this, because some people might say that that just says pi over 2 is less than theta is less than pi, which takes away the meaning. So I want you to discuss, what does that even mean?
Or, whoa, yeah, you're right. Sorry, the second one. Well, I thought that.
I got it.
Yeah, like, okay. No, yeah, yeah, that makes sense. That makes sense. Yeah. Okay.
That means it has to be, the second quadrant, sine's the only big positive.
Are we doing it?
Why that's.
So what does it mean? Okay, can you show me the number that should come to mind from seeing that information? The number is 2 or this, right? Because it's saying that there's an angle that is in between pi over 2 and pi in the second quadrant. So when I do this problem, I'm setting myself up here first. I'm going to start by drawing a picture. Maybe I'll focus on the second quadrant a little bit. And this is just an arbitrary angle. Of course, from this angle, I have to make it a triangle. So how about that? Is that a pretty good triangle? It's a good triangle, but it's completely inappropriate. You go from there and just go directly to the x-axis, perpendicular to it. I'll give you a chance to finish this. Check in with your neighbor when you are done or stuck.
Yeah, I didn't see.
Yeah, so secant is just negative. Or just some cosine.
So what was the
Yeah,
number?
sure. Well, this
This
is
is
R,
oh,
so this is
R.
R.
I saw it.
So this would have to be -1 and this would have to be.
Sine.
Yeah, this is root.
And then cosine I got -1.
Yeah.
It's changing.
So this isn't, secant isn't R over.
For, cosecant, I got 2/√3.
The secant is R.
Yeah.
But that would mean it's
Two over root three. Or like
Yeah.
2/3.
it would be -1.
Two over
Secant, I got
Oh.
-2. And then for cotangent, I got -√3.
Yes.
Okay, I need some help with this. What should I do? I don't even know what secant is, so. Lydia, can you help me out with this one, please?
Oh.
Or do you have a question or an answer?
Answer.
Okay, help us out.
Well. For secant, since it's always gonna be like the radius over cosine, you know that the radius has to be 2. And that, because like the radius can't be negative, and then. So then we put like a -1 as the x. And then you can use just the Pythagorean theorem to get your y side, which I got to be √3.
Positive square root of 3 or negative square root of 3?
Also.
Are we sure it's positive? Are we good with that? How do you know? Because it's up.
Yeah.
Okay, good. Any questions about this? That's really nice that you use your knowledge of secants. That's perfect. Okay, do you want to continue?
Yeah.
It kind of fills itself in, doesn't it?
Yeah.
Okay, so, next one I'm gonna do is cosine. That's actually where I would have started and then done my triangle, because I know I'm more comfortable with cosine. It's weird for me to think hypotenuse over something. It just creeps me out. I like to take it back to SOHCAHTOA, but I love that you just went straight into the secant. That's great. So, sine is √3/2. Tangent is -√3. And then the others are the reciprocals of those. -1/√3. Then you put the negative in the denominator, right? Like you didn't say 1 over -√3, I hope. No, who would do that? Thank you, Lydia. Any questions? Yeah, we're gonna keep going in this direction. Oh, I'm sorry. Stop. There's more. I didn't finish this one. I didn't label theta. Do you see where theta is?
Oh,
Do you see where it is? It's standard position. So it starts where? Here and goes all the way into that second quadrant. So theta is over here. So what's that other one? 180 minus theta if you're in degrees, or if you're in radians, it would be pi minus theta. Do we agree with that? With that angle there, we could label it pi minus theta. But more generally speaking, I'm going to call that theta prime. It's an apostrophe. Theta prime. Theta prime is a reference angle. And we need a reference angle. I'll let you finish copying this down. We need a reference angle because SOHCAHTOA only works in what kind of a triangle? A right triangle. And if here it tells us that our angle, it definitely said it's between 90 and 180 degrees. Is that possible to be in a right triangle? An angle that's obtuse? Completely impossible. So what we have to do is make another triangle. So we have an opposite, adjacent, and still a hypotenuse. This is the reference angle. This triangle is called the reference triangle. It helps us put everything in order with theta. If you plug in a theta here, you're actually talking about an acute angle, aren't you? Think about that. If you put a theta right here, aren't you saying that theta is acute? You tuck that away in there, but it clearly says that theta is not acute. It's between pi over 2 and pi radians. So there's our theta info. We're using this triangle to get all the other values. That's why when it goes past that 90, things get weird. Like, how could the side of a triangle be -1? That wouldn't make sense in geometry, would it? It only makes sense here where we're abstracting, where the quantities are relative where we started. And here, that third quadrant, they're also a little bit different. So I'm sorry to stop your train of thoughts while you go into this one, but let's see what you could do with this. Oh, yes.
Is like the
Oh.
reference angle always called theta prime,
Yeah.
no matter what
Yeah.
quadrant it's in?
Except in the third quadrant.
I don't know the data, right?
No, but we're still finding, because this is. Just.
Yeah, discuss where this triangle is.
It does less.
I mean, it's on the left hand
So
side.
then it just has to be,
How would you?
that has to be the left.
Doesn't mean that like, right?
Pi.
Like, okay, wait, like,
Either be
like.
I might be wrong.
You go to.
I don't think
and
it's-
five. Is your highest on one.
Yeah.
Yeah, I think it's.
Oh,
here. And then they wrong side. I just that's no side that side. All the
Wait.
coordinates.
Why is it going
Like, would this work? Hey, girl.
Well,
Like, right,
It's
because.
not happening, right?
Yeah, it is third.
Uh,
Well, it's like
Maybe
off,
we-
it's off, it's
No,
proportional.
it's like-
That's why.
I'm not sure what you're doing is right or what I'm doing is right.
then it might be that way.
Well, okay.
But you have your cosine.
Like a
Yeah, I think it is that way.
Why?
No, it's cosine
Two
too.
over
Wait, can we check
ten,
these are
sine over
like
cosine.
this?
And that's fine.
No.
And guess what?
Then what if
Okay,
theta just be 180?
so.
10 more seconds of discussion.
It's 180.
I'm not sure what you're.
Negative, whatever that.
What you're. Probably.
Okay, so pencils down for a moment, please. Now, if I were you, this is what I would be thinking. I listened to Mr. Lieberman very clearly. He's very funny and handsome. That's beside the point. Just kidding. Just kidding. And it says a tangent's equal to 2 over 3. So I'm going to put a triangle here because it very clearly. Here's a 2, here's a 3. And okay, so I should finish this problem. But then I keep reading and it says that cosine is
Less than 0.
less than 0. On this triangle, the cosine is definitely greater than 0. So is this just impossible? I need help. I need help because Mr. Lieberman lies, obviously, because that just failed me. So what happened? Yes, Eileen?
Third quadrant
Third quadrant. Why third?
says tangent is positive, so it has to be in either the first or the third. And then cosine is negative, so it has to be in here.
Okay, wait a minute. So tangent, but wouldn't that mean that this is like -2 and this is -3? Would that work out still?
Yeah.
It does. So it's kind of like this originally said negative over negative, but that would be so inappropriate to put negatives there. So we remember that the other quadrants have feelings too. So thank you for remembering about quadrant 3. Did you already start on this one? Now, in my other class, one student did this. Is this okay? They put the triangle in quadrant 3. What's wrong with it? Look, here's a -2, here's a -3. What's the problem?
Terminals.
Yeah, they've lost the whole idea about starting here and rotating about that origin. Yes.
What if you were to like put the triangle back like to where it originally was, and we were trying to find
Here you
the
mean?
theta, or like like the actual like what it's supposed to look like?
Okay.
So how would you like what would the theta angle look like? Because wouldn't it if it just rounds?
Oh, that's a great question. Please check with your neighbor. Where is theta?
That's what we
All right, so if you and your neighbor don't know, check with people behind you, in front of you.
Yeah.
I love that question.
We asked if they did this goal. I have the same thing. Where's data?
Is that literally just it?
Thanks.
But if it's-
Where's theta? Where is it? Can you trace it kind of right here? From here and then goes just until you get to the terminal side.
Oh,
That's by definition, that's always theta. And that's our angle
the terminal side is the side which it comes out.
out of the origin.
That's the terminal.
Yeah, this is the initial side. There it is. That's the terminal side. So it's got to come from that
So
origin.
it's the ring.
It is the radius if we're dealing with a circle there. Nice. Oh, so what's this? Theta prime.
This is the reason. Of the triangle.
Oh, the
Or hypotenuse.
Now theta prime will not be involved in any of our calculations. When we write it, we're still doing sine of theta, cosine of theta, et cetera. Is someone just singing Spice Girls? Like that.
What were you using?
Oh, Britney Spears?
Huh?
What is Britney Spears?
No.
It's Elvis? Interesting. Did he finish?
Yeah.
Did your neighbor finish? Are they all right?
Yeah.
No, but like it's just too weird because it's like the side.
Yeah.
Stop.
Oh, wait. Oh, yeah, wait, the terminal side needs something. Hang on.
So I have a quick question. Would this mess you up if you make your triangle like this? Would this mess things up?
Yeah.
We still have like a -2 and a -3 kind of. How would this mess you up by doing this?
Yeah.
Yeah, the thetas kind of get messed up, don't they? Like it has to come from here, so it's this piece that has to be the angle that we're talking about. So please make sure you're always going to that x-axis when you're making that angle. Okay, so here we have another angle. Okay, standard position. I know it starts off this direction.
Feels like
I'm
it,
not doing all of them because I trust you to
And then it
do them
goes-
correctly.
it's like what?
Huh? Oh.
Oh, wait.
Wait, that's trouble, sir. Wait, how do you even start? Just we're not saying. So the hypotenuse, okay. So the hypotenuse is. I don't
No, I don't do
know.
that.
I know the term of English.
Yeah, that was the other one.
I just think never.
Like a little like sine starts from here, cosine starts from
Compare
here.
function over like
Why
one.
am I at?
Don't worry about it.
Oh,
It's not, because it's not going.
Okay, so do I even have a triangle here? Yeah, coming from that point. That could be here, or you could even go farther down. You could go like over 4 down 2 or something like that, because it is a line that goes forever, but just keep it simple. We know in this triangle, we have, what is that, 2 and -1? So hypotenuse is √5. And by the way, hypotenuse is never, ever, ever negative. Hypotenuse will never be negative and probably always be positive unless it's collapsed to 0, which could happen. Yes. The values for both of these, are you confident that you have them correct? Let me just make sure, like on this one, down here, what's the secant of theta for this one?
Negative. Like, yeah.
Negative what? 13? Over what? 3, is that right?
Yeah.
Okay, so if you have that, I imagine all your other ones are correct. And here, let's do cosecant of theta. This will be on the count of 3. Let's hear it. 1, 2, 3. Negative root 5.
Over one.
Okay. Over 1, which is of course just that.
Wait, section second.
Okay, so that's
Any questions?
Oh, yeah, where would theta be then?
Oh, thank you. Yeah, where's theta? Do you see?
like that.
Yeah.
Theta. And then, of course, in here will be theta
Theta prime.
prime. Although, honestly, we could make an argument that is theta.
The other thing is.
It's just the value of theta is negative. Wouldn't that be reasonable? It's an acute angle and everything. It's fine. It doesn't need a reference angle, but it'd be appropriate if you assuming it's positive, make this theta, in which case this would be theta prime. You could call that theta. Yes.
Wouldn't you have to write like sine negative theta? For example?
Sine of, no, theta is a variable.
So it's saying like when it goes.
No, but like that makes sense.
Yeah, exactly. If you type theta in here, it wouldn't be wrong. But you'd have to argue with me, like if I said, why are you putting theta over there? It should be around the other way. You'd say, oh, it's negative, you just can't see it. Yeah. This one?
Yeah.
Oh, yeah, I didn't mark
We
that.
drew the theta pop when it overlaps with the theta
Yeah.
prime.
Exactly.
But on this, the other one, it doesn't.
Right. They're two completely different angles. Right, this one is, this is definitely acute.
Yeah.
This is more than 180 degrees. And to get to this one, we have to go like they're kind of overlapping. But this, there's a duality of how you could think about this. Yes, you could think about this as theta, but this is a nice acute angle, so that I could just see theta starting from that starting side. And it's not a problem with triangles. Yes.
On an assessment, do you always want us to draw theta prime, or can we just label?
Well, if it says.
Sure.
But yeah, I guess the danger is if you mislabel, if you just, which is very common, if you say that this is theta,
Oh, okay, that makes sense.
would I let it go? Depends on the scope of the question, what I'm really looking for. I'm looking to see if you could fill these in. And I think if you can do the triangle, you'll be fine. Rhea, did you have another question?
No, it was, well, it was like kind of about like even and odd functions, like, is that why, like, if theta was negative and cosine of negative theta is just positive, is that why the 2 is just not negative?
Nice. I do want to talk about even and odd functions next time, so I appreciate you bringing that up. Do you mind if I table that for now?
Yeah, I was just.
I love that. Does that, even in odd functions, does that sound like something you've done in the past? Like, even if you don't remember exactly what it is? We'll revisit old memories next time, and do more of that. I'm gonna give you until 12:37 to zone out or talk about whatever we've done so far before we finish the rest of the material. Yes, Christine?
Yeah.
Wait, I have to channel my inner Mr. Sim.
Exactly.
I think that says Tuesday. Yeah, days 1, 2, 3. What test corrections do?
Tuesday.
Yeah, those are Tuesday. I don't remember the quiz. It's here.
I started. I have those 2 or 3.
Yeah, yeah, thank you, October 1st.
Yeah.
Your points are really hard. Wait, yeah, you remember that?
Mr. Can I go?
That's nice, Bob.
Thank you.
This one I got.
Wait.
The two like when if I fall asleep. This one now gets. This one I was not. No, wakes me up at night, like at 11. Dishes and then I was thinking about. I'm not sure what I don't get to do the dishes as well. I'm not sure what I'm supposed to do. That's that's my question.
Wait, you can cook dinner?
This it works with my size. You know, some of you works here actually based off.
It was just.
That's why I was confused. That's what we have. I was thinking more. I do this out. I didn't see Jeff. I was like, always cooking. I make my own meals. Yes, like I was expecting. Yeah.
to each other.
Like these ones, like, I
And
don't
they like.
really know.
It's together.
This was, I have no idea. This one.
But because it's toxic, they don't.
This one,
understand how to
this
do
one.
it, and they just make it. They like number, they like fish. Protect itself.
Did you say hi?
Yeah. I
You know,
found
it's very good now.
Like,
She's like, okay, I can.
Yeah, I didn't talk to her. Now we have one on it.
Wait, I'm starting to get.
Yeah, but I don't know.
I agree. They have to this.
Oh, this is.
So it's simply, oh, it's.
Okay, this one actually.
Here's.
Amplitude is one.
Wait, why are you saying?
No, the exact.
Because of this now.
They're.
One.
They.
And you can over on that.
Did we have?
Actually.
Hi.
Okay, 12:37, let us move on.
Wait, I don't know.
Thank you for being back from break on time.
I don't.
Aha. Graphs of sine and cosine. You ready to do this?
Yes.
Now, I know that many of you have already seen this. I'm going to it from the beginning, so sorry if this is a little bit slow for you. That's life. Sometimes it happens. For all this, I'm going to be referencing the unit circle. So I'll draw a little unit circle up here. And I don't want to do the entire unit circle. I'm just going to do the easiest points. Even though they're all, once you know them, they're all pretty easy. But how many points are the easiest? 4, like the ones with just integer values. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. Should I mark 0, 0? No, that's not on the unit circle. That's in the unit circle, and it's not helpful at all to have that 0, 0. But we do know that that is the center of our unit circle. And to graph the function f of x equals sine of x, I'm going to make some axes, and they're going to look very specific. I'm going to focus on which quadrants. You know? These are good guesses.
No.
I'm going to focus on 1 and 4. And this probably makes sense to those of you who have seen this before. Like a lot of graphs, you have that origin right in the middle with everything nice and balanced. I want everything kind of focus on the right. Now on this x-axis, now the x-axis represents, if this is sine of x, it represents an angle, doesn't it? And I'm going to have my x values labeled up to 2 pi. Now why 2 pi? We're looking at in a circle that goes up to 2 pi. And if I were doing degrees, instead of going up to 2 pi, I would be going up to 360 degrees. But normally when we graph it, it's in radians. How many pieces am I going to break up that 2 pi into? How many pieces? 4 pieces, because there are 4 quadrants. And I want you to do a really good job when you do this. In other words, once you have that big piece, cut it in half first, because it's easy to cut things in half. And then cut those in half. Right, really try to do a good job. And we'll mark each one of these, and there won't be any surprises here. This is pi over 2, 3 pi over 2. Now the y-axis, I figure out how big does the sine get? What's the very biggest that it gets? 1. It just gets up to 1. We can see that on the unit circle. And the lowest that it gets is -1. And I'm just going to summarize the values here. Like when I say sine of 0, we know that that's equal to sine of 0. That's right here, isn't it? Equals 0, isn't it? Sine of 0 equals 0. Sine of pi over 2, I'm looking up here. Sine of pi over 2 is 1. So I put a point up there. Sine of pi is 0. Sine of 3 pi over 2. -1, and sine of 2 pi is 0. So do I have a big zigzag here if I were to connect these? Is that how it works?
No,
No corners. It's a curve. We're making a sine curve. And again, I want you to look up here for a moment, even though I know many of you know how to do this. I want you to get good habits. I hope it makes sense that this is the only curve that it's composed of. It's there, and then to get the next quadrant, I'm just going to take that and reflect it. Right? So it's going to look something like this. Now, some people think that this is half of a circle. What do you think? Is it possible that this is a semicircle?
It's not.
No? You sure? How do you know? What's that?
I mean, if you like visualize it, I think it doesn't count.
Okay. Is there any proof that that's not a circle, Eileen?
You can't have two points on the same like y.
Oh, but half a circle, sorry, half a circle. Yeah, so is it, maybe that's half a circle? Is that possible? Why? Yeah, circle by definition has a radius. This is one, this is not one. Says it's definitely not a circle, although it comes from the unit circle. Now continuing, I'm going to take that same curve that I have, I'm just going to flip it underneath. Same curve there, and then finish it up with the same curve here. Now, can I continue past 2 pi?
Yeah.
Can you imagine what it would look past that?
Same as the same.
Would it make sense that you just take what I have here, copy, and then paste, paste, paste? How far could we copy that?
Infinity.
For infinity. So I'm just gonna put a little hint there that it continues by doing that. How about, does it start at 0?
Yeah. No, it goes the other way.
It goes the other way, so it's possible for x to be negative? How would that be? That would mean there's such thing as a negative angle, is that right? Yeah, it's go the other way, so it's fine to go the other way. So maybe I should do this, would that be okay?
No.
No, follow the pattern. Okay, continue this. It's still copy and paste, or copy and paste, paste, paste. You only have to copy once, don't you, before you paste?
Yeah.
Okay, so 0 to 2 pi is called the, well, not 0 to 2 pi, it's called the period of this function. Period just means how long does it take before it repeats. Now, if you said that the period is from 0 to pi, that means you just copy and paste this and you just look like going, going, going. And it doesn't look like that. So it's 0 to 2 pi. So 2 pi is the period. And that could also be like here, the 2 pi, but normally we look at 0 to 2 pi. That is a period. And there's another word that you may not have heard with regard to sine and cosine. The other word, amplitude. The amplitude here is 1. It just means the vertical distance to the highest, lowest point. Amplitude. So since it's a distance, we know that that value will always be positive. In this case, it is 1. So period is just the time it takes to repeat. Amplitude is the distance to the high point or the low point from that middle. And anytime you draw a sine wave, I do want you to start with 5 points. So I'm going to highlight these 5 points. So it's like the skeleton of our sine, just like we had skeletons being the asymptotes and the holes and intercepts. These 5 points are the skeleton of the sine wave. Yeah. Let's do, it talks about extrema. Don't worry about that. Extrema just means the high points and low points. Okay, we're gonna do the same thing here. And I want you to just check in with your neighbor to see where this should start. It's still, of course, gonna go to 2 pi, but where should this begin? We're going from 0 to 2 pi.
It starts at 0.
Check in with your neighbor, especially if they're having a hard time. This is some people's very first time seeing it, so be patient.
Yeah.
Yeah, that's what I'm just.
Yeah.
It starts at 1 cm.
Yeah.
That is very true. It's very true.
This part, let's say like.
So where does this begin? When you plug in a 0, you get 1. Are we good with that? When you plug in a 0, you get 1. Cosine of 0 is 1. You all start up here. And then we go to cosine of pi over 2, which we know is 0. We go to pi. Cosine of pi is. Are we sure that cosine of pi is -1?
Yeah.
How do we know? Just look at the unit circle. That's what it's there for. Cosine of 3 pi,
0.
0, and cosine of 2 pi, +1. So don't copy me. So this is cosine.
No.
No, I did a terrible job. It's not a V. We take those 5 points, but we make from that a curve, a smooth curve. Both of these curves are called sinusoidal, by the way. They're both sinusoidal curves.
We need to know that.
Nothing, but I may talk about sinusoidal. Okay, so we have that as a first. Okay. Etc. Etc. Any questions? Um, I'm gonna do a little like really bad animation here just to make sure we really understand what's going on here. The first graph is a summary of the y coordinates going around the unit circle. The second graph is a summary of the x coordinates. So I'm going to do a little animation here. Here's my angle. And if I do this right, I could actually rotate. Yes? So if you follow this along, if I'm looking for a sine, we're looking at the y values. Does it make sense that we're starting at 0, and then as we proceed, we go to 1, 0, -1, 0. Does that follow exactly the information on that sine graph? I'm going to rewind this so I could start over for cosine because I can't just start over there again. The cosine, we're going to follow not the y coordinates, but the x coordinates, where we begin with 1, just like the graph at the bottom does, right? 1, and then goes to 0, 1, 0. Did you guys practice that? That was awesome. Oh, 1, I didn't make it all the way. Any questions? It's just a summary of the x values, summary of the y values for each one of these. And these are 2 new parent functions. So you know I like to have gestures for these. So that like pocket parabola. Did you all bring your pocket parabola? Right here.
Okay, that was.
Parabola. Right. So pocket sine wave. You actually need 2 pockets for it because it's gonna look like this. With your left hand probably on top. I think left hand has to be on top, doesn't it? So is your point of view. Left hand for you, it's left hand on top. So that's your pocket sine wave. The pocket cosine wave. You could totally get into it if you want. But what I normally do is this. I just kind of put up what is it, a shaka? Is that what it's called? Shaka, like Hawaiian. Do you see the cosine that I'm holding up though? Starts up at 1, goes down to -1, comes up to 1. I can't break my finger to actually make it curve though. So but it's just an approximation, okay? Don't break your fingers when you're doing this. Speaking of which, don't break your fingers ever in math class. When you draw yours, I will be taking out points for doing things like this. If your graph looks like this, it can't go above that top point. So please make sure that it doesn't do that. And also if you do something like this, you're just setting yourself up for failure for that first quadrant. Where would you even go from there? I have no idea what you would do. It's going to be a mess. So just chill. The top of the first of the cosine is like the top of a hill and you roll down slowly. Yes, hold on.
Yeah, so when we graph the x and the y, should the space between the half pi, should it be like somewhat bigger than 0 to 1?
Oh, I don't care. You make the scale, just don't make it too small. And don't make it huge either. Make it comfortable, just right. The Goldilocks. Okay. I'm gonna change this problem. So the y equals 2 times cosine of 3x instead of pi x. Before you actually draw this, I want you to discuss with your neighbor. What effect is this 2 gonna have on a graph? What effect is 3 gonna have on a graph?
X is gonna choose.
Yeah.
He's gonna make it longer this way.
Now.
I haven't done this in a year.
Okay, long.
You're about to.
Can you show me what this 2 is gonna do? Can you show me?
Amplitude vertical.
Outside, it stretches it, so, yeah, so our cosine, the amplitude is gonna change, right? The top's gonna come up, the bottom's gonna go down. And this 3, can you show me what that's gonna do?
Increase the period.
This 3 actually, it's the opposite of what you think.
Oh, it's gonna decrease.
Divided by
It impacts.
It compresses it, it's compression by a factor of
It's opposite.
Oh, I
1/3.
Oh,
Does that sound familiar?
that's
Look at this.
It's gonna decrease.
It's decreasing.
Divide over 3.
So all eyes up here, please. All eyes up here. So as I do this, I'm gonna keep it in mind, and lots of you nailed this is amplitude. Amplitude is 2. So I'm just gonna make my standard x-axis like that. So that 2 pi is gonna change by smushing it. How much is it gonna smush? By 1/3. So instead of going out, I'll go to 2 pi, it's gonna go to 2 pi over 3. Does that make sense? And how many pieces do I break this up into? Always break it up into 4 pieces. Someone singing The Little Mermaid? That next one is.
Wait, I messed up.
Wait,
No, you pause. Yeah, you have to do. But I have. Don't you add the percents? Oh, 2 pi over 6.
Pi over 2. First, going from like the next pi.
2 pi over 6.
Okay, how many points do I need to draw? How many points do I need to draw to start? 5 points, please. Goes up to 2, down to -2. This is pi over 2 right here.
Our strength.
Is that clear? You already have that? I mean,
Like, I mean, I don't want to make, your drawing is the same, but it isn't like actually stretched, like, it's not really to scale,
it's definitely not to scale.
like.
Yeah, if I were to do this on this one up here, then I'd have to like change it to like where's 2 pi over 3 right over here. Then you'd see it like a squeeze in there. But you're right, I didn't change the way it looks because I don't want to write so small. But yeah, I've zoomed in on this one. Are we good? This one. Okay, so this right here, I'd like you to think of as pi over 2 x. So this is going to change the period. Discuss what the new period is before you do anything else.
Over past or
Periods.
Periods for.
is it high? Do you take it the ones?
Wait.
I flipped it to something.
What is
Use
it?
calculator.
This is just.
Yeah, but do you remember
over
she's-
variables.
Oh, yeah, yeah.
With the period is like you have to take into account and like that.
Great.
It's not with this.
Oh,
Okay,
yeah.
do you know the amplitude?
Yeah, no, it might be physical. Do you need it?
Amplitude is
No,
three,
it's time to track.
period.
Oh, I think that we did that
Oh.
when we were like.
So think about how we did it last time. We just divided that 2 pi by this number. We're doing the same thing.
So we're dividing it by the practical solve.
You're dividing that 2 pi by pi over 2, which equals,
No, you divide.
is that what it works out to be?
Like
Yeah.
amplitude.
Nice. Yeah, so we have to adjust that 2 pi by dividing out whatever that coefficient of the x was. Okay, so that's a really nice number, isn't it? So easy to subdivide into 4 parts. If it were a 5, that'd be a little awkward. Right. There's a sign, 1, 2, 3, 4, 5. So for all these, I've just grabbed 1 period, but on a test, could you imagine if I say to grab 2 periods, would that be a problem? Just copy, paste, the way they used to have to do it. With a pencil in your brain. I hope that this has made sense. I hope it's not been too much of a brain buster. Let's see, I think we have a couple more down here. Oh, look at that. I can give you time to do whatever you can at the bottom.
Is there one just Pearson?
Yeah. Unless otherwise noted, homework is always Pearson.